Let's examine this situation where the two quantities r and theta are changing such that changes in theta produce changes in r that are twice as much. And just to help you think through this, it might be useful to think about these radian measure angles, pi over 6, pi over 3, pi over 2, etc. But think of it like this, just some rough estimates so your brain can track better what's happening. Here's what I mean. Pi is approximately 3. And so pi over 6, pi sixths is about 3/6, is a half. So if you make an angle that's pi over 6 radians, then that's going to be roughly half a radian. And then pi over 3, pi is about 3, so 3 over 3 is about 1. So 1 radian angle would be about here, 1.5, 2, 2.5, and then 3 when you get over here to pi. Now I'm just roughing it here because you'll see that relationship better, perhaps, with whole numbers than with these irrational numbers. So here goes. So first of all, changes in theta produce changes in r that are twice as much. So let's try to, I'm going to try to zoom in here a little bit. This first spoke here, if you will, was pi twelfths. So about 3/12, so about a quarter. So if you change theta by about a quarter, let me get it there, you're going to create changes in r that are about twice as much, So twice of a quarter should be a half. Now, come on, slow down. All right, so right about in here. And so you can track now these scales here. So it's 0.2, 0.4, 0.6. So when I change theta to about a 12th, pi over 12, which is about a quarter of a radian, then I'm on the circle that's about a half of a unit out from that center. When we get to pi over 6, now pi over 6 is just about a half a radian. So when we get to pi over 6, we should see values of r that are about twice as much, so about 1. Now notice the scale here. This is 0.5 and then 1. A little bit more than 1, of course, because pi over 6 is a little bit more than a half. And then let's do one more. Let's get to pi over 3. Now when we get to pi over 3, that would be just about 1 radian. There we go. Come back, come back, come back. So an angle of pi over 3, and we should say it's about 1 radian, so we should see changes in r that are about twice as much. And you can see the scale there of 2. So we're a little bit beyond 2, since pi over 3 is a little bit beyond 1. But changes in theta result in changes in r from 0. We're changing from 0 each time. We're getting changes in 0 that are twice as much. Now just one more, pi over 2, about 3 over 2 is about 1/2. You guys know it's probably 1.57-ish. So if we run that through, we should see changes in r that are about twice as much, a little bit more than 3. Look at that. This is happening great. Now I'm going to let it run now. And what we see is this spiral-shaped curve. And the question is this a linear function? Does it meet our definition of linear? Well, again, I'm going to zoom in a little bit. Let's see if those changes happen the way that we were anticipating. I created a little bit better here, at least for a couple of iterations. Notice here, we're going to first change theta. So I'm going to change theta from 0, just for convenience. And if I change theta from 0, notice I've gone to pi over 6, which is about a half of a radian, 3/6, about half of a radian. We should see corresponding changes in r that are twice as much. Twice as much would be 1. Now notice the scale here. There's 2, so we're about 1 unit out now along that radius. And just to show another one, a little bit larger one, changes in theta of about 1 radian will produce changes in r that are about twice as much, 2. And so we're seeing the same idea as we saw with our rectangular coordinate system. We can see these so-called calculus triangles, although they're not really triangles, are there? But are they? We're showing the changes just like we were showing the changes previously. And here's the question. Based on our meaning, based on our, shall we call it a definition of what it means to be linear, is this a linear function?